Question 2 on the Unit 5 practice test number 2. Given that f of x equals -4 times quantity x plus 3 times the quantity x minus 2 times the quantity x plus 2, what are the zeros? What is the degree? Rewrite f in standard form. Describe the end behavior. We can now do the zeros. In question 1, we had the standard form. We didn't know the factors. We couldn't do the zeros, but now we can. Zeros are things that make f of x 0. So my first one is x equals -3. Because if I put -3 where x is here, I'll have -3 plus 3. I get 0. I multiply 0 times 3 other things. My answer has to be 0. Likewise, if I get 0 here, which means x equals 2. I would get 0 here. It doesn't matter what these are. F of x is going to be 0. And my last 0, as you can imagine, would be -2, because that will make this 0. Okay. The degree of f. When I rewrite f in standard form, I'm going to multiply all these together. I'll end up multiplying 3 x's together. My maximum exponent is going to be x to the third, so my degree is 3. When I rewrite it in standard form, first of all, I will multiply x plus 3 times x minus 2. And I'm going to do that over here, just to give myself a little more room. And I'm going to use the box. X times x is x squared. X times 3 is 3x. -2 times x is -2x. And -2 times 3 is -6. So I'm going to have x squared. 3x minus 2x gives me a plus 1x, or just x, and then minus 6. I also have to multiply by the x plus 2. So I will take this and multiply it by x plus 2. X times x squared is x third to the third, which gives me my degree. X times x is x squared. X times -6 is -6x. 2 times x squared is 2x squared. 2 times x is 2x. And 2 times -6 is -12. So I have x to the third plus x squared plus 2x squared gives me a plus 3x squared. Minus 6x plus 2x gives me a minus 4x. And then I have minus 12. To do the final, to get it in the final standard form, I have to multiply by my -4. So -4 times x to the third minus 4 times 3 gives me a minus 12 x squared. Minus 4 times -4 gives me a plus 16, because a negative times a negative is a positive, and it's -4 times -4x, so I have 16x. And then lastly, I have -4 times -12, which is a positive 48. And lastly, I describe the end behavior. I'm going to look at this end behavior. We could look at the maximum exponent like we did in question 1, but I'm going to look at this in terms of the individual factors. Nonetheless, I start off with as x approaches infinity. Secondly, I will do as x approaches negative infinity. But I'm looking at what happens to y. So x is approaching positive infinity. That's going to make this positive because I'll have a number much bigger than 3. I'll have a number much bigger than 2, so this will still be positive even though I'm subtracting. And if I have a big number plus 2, that will be positive. So I have 3 positives, but then I multiply by a negative. So my answer will ultimately be negative. As x approaches infinity, y approaches negative infinity. Secondly, as x approaches negative infinity, I have a really large negative number. It will be much bigger than 2, so this will be negative. Negative minus a negative is certainly going to be a negative, and I'll have a number much bigger than 3, so even though I add 3, I'll still be negative. So now I'm multiplying 2 negatives together, I get a positive. Positive times a negative gives me a negative, but then that negative times a negative is going to give me a positive. So when x approaches negative infinity, y approaches positive infinity.